C. So this is 3/5 times x to the minus 1. Now, you can't use the power rule on x to the minus 1. You have to think of it as 3/5 of 1 over x. And the antiderivative of 1 over x is that special case. It's ln, the absolute value of x. And this one, 5 times 1 over square root of 1 minus x squared. That's that special antiderivative is arc sine. Or it's the negative of arc cosine. And if you wrote it, you could also write it sine inverse of x. And this one, well, secant by itself we don't know. But if you distribute this to these two, you get secant squared x plus secant x tangent x. And secant squared is the derivative of tangent of x. And secant of x tangent of x is the derivative of secant x. Okay, now we're supposed to get the exact answer for these. So we need to do the antiderivative of 2x, which is x squared. And the antiderivative of sine x is minus cosine x. Evaluated from 0 to pi. So we get pi squared minus cosine of pi minus 0 squared minus cosine of 0. Now pi squared will stay pi squared to be exact. Can't go to the calculator. Cosine of pi, if you go to pi, which is over here, the cosine is minus 1. So we got minus a minus 1, which is plus 1, minus 0, and the cosine of 0 is plus 1. So minus a plus 1. So we got minus a minus, which is 1 minus minus 1 is 2. Now this one's a little tricky. Absolute value of x squared minus 4. X squared minus 4 is x plus 2, x minus 2, or it's a parabola down 4. So it's going to look like it's going to go through minus 2 and plus 2. It's going to look like this, and we're supposed to go from 0 to 5. And if we're going from 0 to 5, and we're taking the absolute value of this, the absolute value of this doesn't look like this. Everything that goes negative is positive, so it goes like this. So we've got positive area here, and we've got to change this to positive because of the absolute value. So we have to go the integral from 0 to 2 of the opposite of this, negative x squared plus 4, plus the integral from 2 to 5 of x squared minus 4. Now the antiderivative of x squared is 1/3 x to the third plus 4x, and that's evaluated from 0 to 2, plus 1/3 x cubed plus minus 4x, and that is evaluated from 2 to 5. And so we get 8/3 plus 8 minus, and 0 in this is 0, plus 125 over 3 minus 20 minus, and putting 2 in here, we get 8/3 minus 8. So we have minus 8/3 minus 8/3, that's minus 16/3 plus 125/3 is minus 16 from 125 is 119, 109. Thirds, and then we have minus 20 plus 8, which is minus 12, and that will equal, see, 3 goes in there, 3, 6, and 1/3. So we have 36 1/3 minus 12, which is 24 1/3. Just to be sure, I'm going to check that on my calculator. See that we get that. On, and y equals, and we have the absolute value, math, number, absolute value of x squared minus 4. So let's graph that. So you see how it flipped that nose up. And we want to evaluate this from 0 to 5. Second, find the area, number 7, from 0 to 5. 32 1/3. So what did I do wrong? 32 1/3. So this is 125 over 3 minus 8 over 3. So that's 125 minus 8 over 3 is 125, 117 over 3 minus 8 more, which is 117 minus 8 is 109 over 3. 3 goes into 10, 8's 1, 3, so 109 over 3 is 36.33, 36 1/3, yes. And then we have, if we put in the 2 into this, that's 8x. And we put into that is minus 8. Minus 8 is plus 8. 8 plus 8 is 16. Oh, I forgot an 8. 16 minus 20 is minus 4. So 36 minus 4 is 30, 32 and 1/3. My mental math was off. There we go. All right, this one. So the integral of 1 over x is ln absolute value of x plus, and this is x to the 1/2. Its integral would be x to the 3/2 times 2/3, or divided by 3/2. And we have to evaluate that from 1 to 2. Now 3/2 is x times the square root of x, 1/2 and 1, 3/2. So we have ln 2 plus 2/3 of 2 square root of 2, or we could put 2 in there, and it'd be 2 to the 3/2, or 8, 8 to the square root of 8, or 2 squared 2, minus, put 1 in, and ln of 1 is 0, and this would be plus 2/3, and this has a square root, this doesn't, so we can't combine anything other than drop that, so we get ln 2 plus 4/3 square root of 2 minus 2/3. And we can check that with the calculator. We can figure out that decimal answer and plug that into the calculator and do the area. All right, last page. Determine the capital F of t if f little f of t, the derivative, looks like this. So we have to find the antiderivative of this. So this would be 3, so it would be 4/3 t to the 3 plus t squared plus some constant to get the general antiderivative. That would be f of t. But if f of 0 is supposed to be 5, and we put 0 into this, we would get c. So that tells us that this part would be 0, and so this would have to be 5 to come out with 5. So c has to be 5, so our final answer is this is 4/3 t to the 3rd plus t squared plus 5. Okay, so now we have a velocity graph, seconds and meters per second, and we're supposed to determine the position relative to its starting position after 10 seconds. So in other words, how much did it change in position? Okay, so this is position. So we've got positive area, negative area, and positive area in the first 10 seconds. So what's this area? Well, this looks like about 2.5, and the height looks about 9. So we have 9 times 2.5, but only half of that because it's a triangle. Over here it looks like 8.5. Let's see, it just looks like 2 squares, and a square is 1 by 2, so it's 2. So 2, 4. So it looks like about 4 over here. And this looks like, let's see, that's 9 times 2, 18, 22.5 divided by 2, 11.25. So it looks like about 11.25. These are estimates, so you might have a little different. So we got 15.25 there. Now this is a triangle. You could do it in two pieces, but you could do it one. 2.5 to 8.5. That's 6. And the height is -9. So 6 times -9 divided by 2, because it's a triangle, half as much. So that'd be basically 3 times -9, which is -27. So we have -27 and +15.25. So -27 plus 15.25. So that's 11.75 approximately meters, and it would be, and it's negative, so if moving to the right is positive, it's negative, or it's 11.75 meters to the left of where it started. Okay? Now we could also do it look like this. This and this are basically the same area, and this, and that's about 1.5, about 1.5. That's about the same area, so we could just calculate that trapezoid, which is 2 wide and average of about -246. -6 by 2 is -12. So I would accept also 12 to the left. Something like that would also work very well. Close to the same answer. Determine the total distance traveled. So that would be 11 and 27 and 4. If we just add them up, 11, 27, and 4, because we just make this area positive, so that'd be 31, 42.25. Or 43, something like that, 40, somewhere at 42, 42.25, whatever. They're in that neighborhood. This one, we just have to evaluate this, letting I be -2, -1, 0, 1, 2, 3, 4. So if I is -2, -2 squared is 4, -2 is 2. -1 squared is 1, -2 is -1. Put in 0, we get -2. Put in 1, we get -1. We put in 2, we get 2. 4 minus 2, 2. And I put in 3, we get 9 minus 2, 7. And we put in 4, we get 16 minus 2, 14. 4, 16. 4, 3, 2, 1, 0, -1, -2. There, we got them all. So that would cancel this, and wait a minute. -1, -2, -1, 0 is -2, -1. Okay, so yes, those cancel. So I got -2 plus 2, those will cancel. So I got 7 plus 14, which is 21. There is a place to do that on your calculator too, but I don't need to show you that. Now this one, we've got to write a summation for this series. So we have 2, 3.5, 5, 6.5. Let's see, they're going up by 1.5, 1.5, 1.5. Okay, so it's going up by 1.5. So I'm going to have to do 1.5 times I, and let I start at, let's just have it start at 1. And if I do 1 for that one, 1, 2, 3, 4, 6.5 plus 1.5 is 7/8. 9.5, 1.5 would be 11. So 1, 2, 3, 4, 5, 6, 7 of these. Now if I put in 1, I get 1.5. I'm supposed to have 2. If I go plus 0.5, that would make it 2. Let's check the next one. If I put 2, I get 2 times 1.5, which is 3, plus a half would be 3.5. And if I put in 3, I get 4.5, plus a half would be 5. So that works.